Now, one interesting example for 13.9 is many things in use mathematical models. For example, a quadratic model for profit. There's several ways to develop types of models. One model that people use is least squares often. In constructing a model to represent a particular phenomenon, the goals are simplicity and accuracy. So the least squares regression line 13.18 theorem says that the least squares regression line for a set of all points is given by f of x equals ax plus b. It's a linear function like mx plus b, where a is this complicated formula of sums and products of sums, and b adjusts according to what a is. Now, this looks neither simple, doesn't look simple, but it's accurate. Now, what some people have learned, if this is n times the sum from I equals 1 to n of xi to yi minus these separate sums divided by n times the sum squared minus the separate sum squared. What does that do? Well, someone realized that if they could make this sum 0 by balancing x properly, this thing also becomes 0, and 0 squared is 0. 0 times anything is 0. So they could effectively cut both of these out by making that thing 0. Furthermore, they could cut this portion of b out if it were 0. Now, if a is reduced to this, n divided by n is just 1, so this goes away. So you're essentially, by balancing the x values across zeros, where the sum of all of the x values is 0, they realized, hey, this works for me. So what happens here? It reduces this equation, a, to just this summation down here. The sum of I equals 1 to n of the x's times the y's, divided by the sum from I equals 1 to n of all the x's squared. And then b is just 1 over n times the sum of all of y's squared. So find the least squares regression line for the point -3, 0, -1, 1, 0, 2, and 2, 3. So what do I need here? Okay, we've got an x value. I need my y values. It says I'm going to have to square my x values for this thing, but I also need to multiply my x's times my y's. So let's -3, 0, -1, 1, 0, 2, and 2, 3. And then it also says I'm supposed to be summing all my y's. I need to sum all my x squareds, and I need to sum all my x, y, yi's. Okay. Now, what is the rule here? It says, we'll talk about this in a second. It says that the sum of all of my, I need the sum of all my x values to be 0. We'll deal with that in a second, though. Here, yeah, I need to sum all my x values to 0. So how can I do that when all of my x values, in fact, don't sum to 0? What happens if we do an x shift here? Or it says to do it 2 ways, we're only going to do it 1. I'm going to have to do an x shift here in order to get this to work. Because right now the sum of all my x values aren't 0. What is the sum of all my x values right now? -2. What's the average of them? -2 divided by 4. That's -1/2. So in order to get all of my x values 0, I need to move them all +1/2. So for a second here, let's let u equal x plus 1/2. Just for the sake of argument. So let's see, what is u? That would be -3 plus 1/2, so -2.5, -0.5, 0.5, and 2.5. Now, if I want to use this formula, I need to now use u instead of x. So we really want to do u squared and u times y, because I needed to balance my x's, so I can go back here in a second, but we'll get a formula in terms of u and then use our relationship for u to go back to an equation for x. So what's u squared? 6.25, 0.25, 0.25, 6.25. The sum of all my y's is 6. Sum of all my u squareds, 6, 12 and a half, 13.